Okay, now we are to do, sorry, I'm going to do some example questions. So before I do the example questions, now have a look at my cheat sheet. Okay, I have updated the new relevant information on my cheat sheet. Okay, so I'm going to use my cheat sheet. Okay, I printed it out, but I put it next to me. Okay, so you should do the same. Okay, we have a satellite in a circular orbit around the Earth with an altitude this much. Okay, so just remember, okay, when we're talking about altitude, okay, this is not your radius. Okay, the radius, okay, of the satellite from the center of the Earth, okay, will be the altitude in meters plus the radius of the surface of the Earth. Okay, so you find it in your notes, it's a very big number, add them up, so that's your radius. Okay, so what is the weight of the satellite? Okay, use your equations. Okay, the weight force will be J big M small m divided by R squared. So put down the relevant information in, then you will have the answer. Okay, just remember the radius is the altitude plus the radius of the Earth. Okay, now just let me explain that in a little bit more detail. Okay, so in case, well, this is the planet Earth. Okay, now this is the surface. The radius of the Earth will be called, well, to the is the radius of um, the Earth. Okay, from the center to the surface. Okay, however, the altitude is from the surface, means from the surface to the point. Okay, we call this an altitude. So if a satellite is is flying at this altitude, okay, the total radius, okay, from the altitude to the center of the Earth is the altitude plus the radius of the Earth. Okay. Okay, now look at this question. Okay, so a satellite has a weight of 400 Newton. Okay, now at what distance from the Earth's center will weight 100 Newton? So it needs to be further away. Okay, force 1, okay, force 2, 100 Newton. Okay, now look at my cheat sheet. Okay, so remember this, the ratio equation, J1, J2, the gravity at one point. Well, just make a note, this only works for the same planet. Okay? It only works for the same planet. So in this case, okay, the planet is the same, so we can use that. Okay? The ratio between J1 and J2, okay, will be the ratio between R2 square divided by R1 square, inverse proportional. Okay, so what we do is, also since the satellite, since the satellite, well, the weight force of the satellite changes. However, the mass never changes. So, if we just do this, remember F equals to mj. Okay? Force is directly proportional to gravity if the mass doesn't change. In this case, the mass doesn't change. So F1 divided by F2 must be J1 divided by J2. Okay, so we put it in an equation. 400 divided by 100 must be equals R2 squared divided by R1. Now, at position 1 is Earth's surface, so it's the radius of the Earth squared. Right? Solve this equation. Okay. So if you rearrange the equation, it will be this. Okay. Now, yep. Okay. Then you'll be able to find out this. Okay. So you put it into your calculator, you will be able to find it. Okay. Now, the radius of Earth should be in your textbook or distance education notes. I can't remember it now. Okay, I should put it on my cheat sheet, but I didn't. I made a bad mistake. So you should check it out. Now, let's go on to the next question. Now, okay, now have a look. Okay, it is again a ratio question. Okay, now we have a planet, well, Pluto, blah 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 blah. Okay, now the radius of Pluto to the Sun is this much. Okay, write it down. Now we have a new Eris, okay, another planet. Now, okay, the radius is of well, the radius planet Eris orbiting the Sun will be, I name it RE. It will be 10.5 times 10 power of 12. Okay. Now, also, yes, sorry guys, I made a mistake. It's kilometers. Kilometers. Okay. So I need to 10 power of 3. 10 power of 3. Okay. In meters. Oh, sorry. Nice. No, I didn't make the mistake. I got confused. Because question gives a value like that. Okay, now which one below gives the estimation of the ratio, the gravitational force between the Sun and the Eris, and the gravitational force between Sun and Pluto? Again, use the equation use the ratio equation. Okay, so the gravitational of Eris divided by the gravity of Pluto must be the radius of Pluto squared divided by the radius of Eris squared. Okay. Inverse proportional. Okay. Put it in your calculator, find the answer. Okay. Put this in your remember it's squared. Okay. The number squared. Now, then you should have an answer.